This video attempts to explain problems in probability which are used in grade 11 and 12 mathematics. A and B are said to be independent if the occurrence of A does not depend on B. So in mathematical language, we say probability of A intersection B is probability of A intersection probability of B if A and B are independent. If A and B are not independent, probability of AB is same as probability of A intersection B. That is probability of A into probability of B given A. And probability of BA is same as probability of B intersection A, which is probability of B into probability of A given B. We have the addition theorem which states that probability of A union B is probability of A plus probability of B minus probability of A intersection B. A and B are said to be mutually exclusive if A intersection B is the empty set. That is, probability of A intersection B is 0. And A and B are said to be mutually exclusive and exhaustive if A intersection B is empty and A union B is S. So coming to problems, in a certain school, 20% of the students failed in English, 15% failed in mathematics, and 10% failed in both English and mathematics. A student is selected at random. If he passed in English, find the probability that he also passed in mathematics. So let E be the event that the student failed in English. Probability of E is 20 by 100 since you are given that 20%. So probability of E is 20 by 100. M be the number of students who failed in maths. Probability of M is 15 by 100 since you are given 15%. So probability of E complement will be 80 by 100, which is 1 minus 20 by 100. Probability of M complement will be 1 minus 15 by 100, which is 85 by 100. Probability of E intersection M, that is the number of students who failed in English and maths, is 10. That is 10 by 100. Now using the addition theorem, probability of M union E is probability of M plus probability of E minus probability of M intersection E. That is 20 by 100 plus 15 by 100 minus 10 by 100, which is 25 by 100. We need to find the probability that a student passed in English, passed in maths, given that he passed in English. So I need to find probability of M complement given E complement. That is probability of M complement intersection E complement by probability of E complement. Now probability of M complement intersection E complement is probability of M union E complement. That is 75 by 100. Since probability of M union E is 25 by 100. So substituting here, probability of M complement given E complement will be 75 by 100 by probability of E complement is 80 by 100. So that is 75 by 80, which is 15 by 16. Coming to the next problem, a bag contains 8 red and 5 white balls. 2 draws of 3 balls are made without replacement. Find the probability that the first draw gives 3 white balls and the second draw gives 3 red balls. So we need to find probability of white, white, white in the first draw. That will be 5C3 by 8 plus 5, 13C3. We are choosing 3 red out of 5 red, 3 white out of 5 white, and 3 total out of 13 total. Now since they are made without replacement, we have totally 10 balls left. So the number of red balls remains 8. So probability of red, red, red would be 8C3 by 10C3. So your answer would be 7 by 429. Next question. A and B throw a pair of die alternately. In order to win, they have to get a sum of 8. Find their respective probabilities of winning if A starts the game. To get a sum of 8, we can have these possibilities, that is 2, 6, 3, 5, 4, 4, 5, 3 and 6, 2. There are 5 in all, and when 2 die are rolled, there are 36 possibilities. So P, which is success, is 5 by 36, and Q, which is failure, which is 1 minus P, is 31 by 36. Now given that A starts the game, Probability that A wins is probability that A wins in the first trial or in the third trial or A wins in the fifth trial and so on. Because the trials you're given that A and B throw a pair of die alternately. So probability that A wins will be P plus third trial, so first and second will be QQP. So fifth trial will be QQQQP and so on. So we can take out the P and it will be 1 plus Q squared plus Q raised to 4 and so on. That is, so this is a GP with first term 1 and common ratio Q squared. So it is P by 1 minus Q squared. P is 5 by 36. Q is 31 by 36. So substituting you get 0.537. So probability that A wins is 0.537. We need to find probability that B wins. That is 1 minus 0.537 because either A wins or B wins. So this answer is 0.463. Next question, a bag contains 2n plus 1 coins. N of these coins have a head on both sides while the rest of the coins are fair. A coin is picked up at random from the bag and tossed. If the probability that the toss results in a head is 31 by 42, find N. Probability of head is probability that either we draw a fair coin into probability of head given that a fair coin appears, or probability of getting a biased coin into probability of head given that a biased coin appears. So probability of head is 31 by 42. Probability of a fair coin is n plus 1 out of 2n plus 1. And probability of a head given that a fair coin appears is half. Probability of a biased coin, there are 2n plus 1 minus n plus 1. So n coins are biased. So probability of a biased coin will be n by 2n plus 1. And probability of head, because you are given that it is n of these coins have a head on both sides. So probability of a head given that a biased coin appears would be 1. So we get 31 by 42. LCM is 2n plus 1 into 2. So it is n plus 1 plus 2n. So 31 by 2n equal to 3n plus 1 by 2n plus 1. Cross multiplying, we get 31 into 2n plus 1 is 21 into 3n plus 1. So your answer is n equal to 10.